Hi, I'm Alex. This is Oh, That's Why, a podcast about JavaScript, finally making sense. Let's dig in. An object is just key-value pairs. That is the definition everyone learns on day one. A name, a value. Another name, another value. Curly braces around the whole thing. Simple. And it is true. But here is what that definition does not tell you. Why can you loop over some properties of an object, but not others, even when both are clearly sitting right there when you log the object to the console? Why does Object.freeze sometimes feel like it worked and sometimes feel like it did absolutely nothing? Why do some properties throw an error when you try to reassign them, while others just silently refuse and let your code carry on as if nothing happened? If an object is just key-value pairs, none of that should be possible. A value is a value. It is either there or it is not. But it turns out a property in JavaScript is not just a value. It is a value with a set of rules attached to it, rules that are invisible unless you specifically go looking for them. Most developers go years without knowing those rules exist, because in everyday use, you never have to look. Today we go looking. Picture a museum exhibit. Each item on display sits in its case. But next to every item, there is a small placard. And the placard does not just name the item, it carries a set of rules about it. One line says whether visitors are allowed to touch the item. Another line says whether the item is listed in the printed catalog you picked up at the entrance. Some items on display are intentionally left out of the catalog, even though they are sitting right there in the room. And a third line says whether the museum is allowed to move the item to a different room, or remove it from the exhibit entirely in the future. 3 quiet rules, sitting on a small card, easy to miss. Most visitors never read the placards. They just look at the item. But the placards are doing real work. They determine what can happen to that item going forward, regardless of how valuable or interesting the item itself is. Every property on a JavaScript object has one of these placards. It is called a property descriptor, and it has exactly 3 settings that matter. Writable. Can the value be changed? Enumerable. Does it show up when you loop over the object or list its keys? Configurable. Can the placard itself be edited later, or can the property be deleted? When you create a property the normal way, object.property equals value, JavaScript attaches a placard with all 3 set to true. Writable, enumerable, configurable. Fully open. That is why, in everyday use, you never notice the placard is there. Every property behaves exactly like a plain value, because its placard places no restrictions. But the placard can be changed. And once it is, the property starts behaving differently, even though if you just log the object, it looks exactly the same. Here's what's actually happening underneath. To read or change a placard directly, JavaScript gives you Object.define property. You give it the object, the property name, and a descriptor: value, writable, enumerable, configurable. If you define a property with writable set to false, attempts to change its value will silently fail in normal mode or throw an error in strict mode. The property still exists. You can still read it. You just cannot change it. This is different from const, by the way. Const stops you from reassigning a variable to a new value entirely. A non-writable property stops you from changing the value of one specific property on an object, while the object itself and all its other properties remain completely normal. If you define a property with enumerable set to false, the property still exists, you can still access it directly by name, but it will not appear in a for-in loop, will not appear in Object.keys, Object.values, or Object.entries, and will not show up in JSON.stringify. It is there. It is just left out of the catalog. This is exactly how some built-in properties on objects and arrays work, present and functional, but not cluttering up the listings. If you define a property with configurable set to false, you cannot delete it, and this is the part people miss. You cannot change its descriptor again afterward, with one narrow exception around writable. The placard, once non-configurable, is largely locked. Whatever rules it had when you locked it are the rules it has forever. Now, Object.freeze and Object.seal. The two blunt instruments most developers have heard of, without necessarily knowing what they do underneath. Object.seal makes every existing property non-configurable. No new properties, no deletions. But if a property was writable before sealing, it remains writable after. You can still change values. You just cannot add, remove, or reconfigure. Object.freeze does everything seal does, and additionally makes every property non-writable. Nothing can be added, removed, reconfigured, or changed. This is the closest JavaScript gets to true immutability for an object, and it is still only shallow. If a frozen object contains a nested object as one of its property values, that nested object is not frozen. Its properties can still change freely. Freeze only locks the placards at the top level. This is why Object.freeze sometimes doesn't work. People freeze an object, then mutate a nested object inside it, and are confused when the mutation succeeds. The outer placards were locked. The inner ones were never touched at all. The silent failure trap is the one I see most. In non-strict mode, attempting to write to a non-writable property does not throw. It just does nothing. Your code continues, the value is unchanged, and there is no indication anything went wrong. If you are working with an object you did not create, maybe a frozen configuration object from a library, and a value silently fails to update, this is the first thing to check. In strict mode, which is the default inside ES modules and classes, the same operation throws a type error instead. Far easier to debug. One of several good reasons modern JavaScript leans on strict mode by default. Second trap, assuming Object.freeze gives you deep immutability. It does not. If you need a fully immutable nested structure, you need to recursively freeze every nested object yourself, or use a library built for it. A single top-level freeze call protects exactly one level. Third trap, the modern shorthand syntax. It makes object creation faster, but it can obscure what's actually happening. Computed property names let you use a variable's value as a key. Shorthand property names let you write just the variable name when the key matches. Spread syntax copies the enumerable own properties of another object into a new one. And here's the detail that catches people. Spread only copies enumerable properties. If a property was set to non-enumerable, spreading the object will silently drop it. No error. The copy just looks complete and isn't. And destructuring, pulling properties out into individual variables, reads values normally, but does not care about or preserve any descriptor information. Destructured values are just plain values, with fresh, fully open placards if you reassign them. Every property in JavaScript is not just a value. It's a value plus a placard of rules about that value. Writable, enumeration, configurable. Once you can see the placard, objects stop being mysterious. Most properties you ever create will have fully open placards, and you will never need to think about any of this. But when something behaves strangely, a property that won't update, a key that's missing from your loop even though it's clearly there, a freeze that didn't seem to freeze anything, the placard is where the answer lives. The companion article on Medium has a full walkthrough of Object.define property, with working examples of each descriptor setting and what changes when you flip it. Link is in the show notes. Next week, prototypes and the prototype chain. Why does every array have .map without you ever defining it? The answer connects directly to today, because it turns out the prototype chain is also just objects, with their own placards, linked together in a very particular way. I'm Alex Vega. This is Oh, That's Why. Next time an object does something you didn't expect, check the placard. See you next week.